Okay, let's talk about 0-point errors. 0-point errors are those that occur when you don't put 0 where it belongs. So for instance, in the case here, I have 2 pennies on 2 electronic balances. One balance says it is 0.9 grams, and the other one says that penny is 2.5. Now either these are 2 very different pennies, or I might have a 0-point error problem. So the way you check for 0-point errors is simply remove the material, and if there's no material, it should go to 0. So this one goes to 0, so therefore I am pretty confident that that penny does have a mass of 2.5 grams. When I come over here to the penny that's 0.9 grams, if I remove this, what I see is when I have 0 matter on the balance, instead of seeing 0, I see 0.17. So balances are a common, electronic balances are a common device we use in this class. They are prone, very prone to 0-point inaccuracies. So what we have to do is always periodically check, make sure there's nothing on the balance, and then just hit the 0 button. When you hit the 0, it'll go to 0 grams. Now when I put this on here, this one says 2.5, which agrees with this one over here. Accuracy means agreement, and we have corrected for 0-point inaccuracy. Now there's other ways. If I want to measure the weight of something, I'd use a bathroom scale. So let's just say I want to take this piece of lead and put it on here and measure the weight. Now I also had to make sure about parallax errors. Look at that. Ooh, all kinds of parallax errors. But I'm going to look at it straight up and down. It says it's 30 pounds. Well, that seems pretty heavy to me. I don't think I'm quite that strong. So I'm going to remove it and see what I have here. And it says it's only 20 pounds. So 0 is clearly, look, there's nothing on here. And so it should be reading 0. I don't know if you've ever done this to anyone at home, but it's a mean little trick you can play on people. So what I'm going to do is I'm going to look underneath it and see if I can find a little knob to twist. I'm having a hard time locating it. Where is my knob to twist? Darn it. There's a little knob I can twist right there. So I'm going to twist that knob and get myself back to 0. And now with 0 on it, it says 0. So when I put my lead on here, it tells me it has a weight of 10 pounds, which is more accurate. Now you can also have 0-point errors associated with, say, measuring liquid volumes using a graduated cylinder. So if I take a graduated cylinder and look at it, I have to be careful. If there's any liquid left in the bottom of it, which is not hard to do when you're doing a lab, any liquid in the middle, in the bottom rather, is going to contribute to 0-point inaccuracy. So if I take this here and pour it into here, I don't really know what it is, because when I pour it in and I take a reading off of here, and I look at it and I read from here to see what it is, unfortunately, since I don't know how much liquid was in there to begin with, my 0 point is off, so I will get an inaccurate reading. I can read this as with all the precision I want, but I'm not going to be accurate, so the value is not useful. And finally, another measuring device we often use in this class is a measuring stick, a meter stick. So if I put it here, again, remember, this is not a good way of doing it because of the parallax error problem. Oops, got a little bit bright there. So I'm going to rotate over this way, and let's see here. It looks to me like this sheet of paper I have here is about 22.6 centimeters long, except look over here. Whoops, 0 is not in the right place. So it's very easy to get 0-point errors here. You have to make sure that you have 0 in exactly the right place. Then you can come over here and get an accurate value. But if 0 is in the wrong place, you'll always be wrong. 0-point errors are easily correctable simply by making sure that 0 matter equals 0 of the measurement.